Welcome to basic substitution examples. So recall for U substitution, we look for an integral involving composition. So we look for composition inside the integral. And we replace the inside function with U. Then our goal is to force the integral into the format integral of f prime of u times the derivative of u with respect to x times dx. Du dx times dx is precisely the definition of du. So this is equivalent to the definite integral of f prime of u du. And then we just integrate with respect to u. And so we wind up with f of u plus c. So let's go ahead and take a look at an example. Let's evaluate the indefinite integral of secant squared of 3x dx. So in this case, we do have composition. We're looking at secant squared of 3x. Technically, we have two compositions here. We have squaring the secant and then taking secant of 3x. So we do have two compositions going on here. Secant squared is a function we know the derivative of. So secant squared is a known derivative. And then we have an inside function of 3x. So we'll go ahead and set u to be equal to 3x. If u equals 3x, that means that du would be derivative of 3x is 3 times dx. So going back to our integral, we are looking at the integral of secant squared of 3x dx is the same thing as the integral of secant squared of u dx. We have two options here. One option is to solve for dx. So, but du equals 3 dx. And so that means that dx is equal to 1/3 du. The other option is to just multiply by a 1/3 times 3 to force our 3 dx. But I find this option to be the easiest. At this point, we are looking at the integral of secant squared of u times 1/3 du, or 1/3 secant squared, in 1/3 times the integral of secant squared u du. Again, integral of secant squared is one we know. This is just 1/3 times tangent of u plus c. Our last step is to plug back in u equals 3x. And so we wind up getting that the integral is 1/3 times tangent of 3x plus c. Again, let's go ahead and do another example. This time around, we're going to evaluate the indefinite integral, the integral of 5 over 2x minus 7 dx. So that 2x minus 7 is all in the denominator. So just a note. One over x is a known derivative. That comes from the derivative of natural log absolute value of x is 1 over x. And so we can use this sort of something over x as our outside function. Our inside function will be that denominator of 2x minus 7. So we'll go ahead and set that denominator 2x minus 7 as our u. That means that our du is 2 times dx, or equivalently, dx is 1/2 du. So we can go ahead and then plug these back into the original integral. So we have the integral of 5 over 2x minus 7 dx is the same thing as the integral of 5 over u times 1/2 du. This is just 5/2 times the integral of 1 over u du. Integrating that, we get 5/2 times natural log of the absolute value of u plus c. And then again, our last step is to plug in u equals 2x minus 7 back in. And we wind up getting that our integral is 5/2 times the natural log of the absolute value of 2x minus 7 plus c. So this is doing a couple basic indefinite integrals using u substitution. In the next video, we'll look at some more examples, and as we work our way forward, we'll see some more variations of u substitution where the substitution is not quite so obvious.